So plants have many advantages, and vegetation, when we're talking about climate, and particularly in cities, if we're talking about climate change, one of the big problems that most of the world's population in the future are going to be living in cities, which are going to be even hotter than the rest of the globe because we have what's called urban heat island effect, where because of all the cement and the roads and the materials used in the cities are actually slightly warmer than the surrounding areas. But one of the main impact of vegetation in the cities is a cooling effect, because as we mentioned before, most of the energy that is intercepted by the plants, whether it's in the city or outside the city, goes to evaporation or evapotranspiration. And without those plants, that same amount of energy would go to heating the surface. So when we have vegetation in a city, or we have parks, trees, those regions are actually cooler than the rest of the city because of this effect of the energy of the sun going to evapotranspiration and actually cooling the air. But there are many other benefits for having the plants. Obviously, they absorb carbon dioxide through photosynthesis. They actually can cool the buildings and reduce the demand of use for energy, for air conditioning. They can take out pollutants out of the air. They can absorb particles and various pollutants in the air and prevent them from entering our lungs. Obviously, they also intercept rainfall and storm waters, and in their roots they can have in the ground the water, which if we don't have those plants and we cover those regions with asphalt and cement and roads, the water can result in more flooding and runoff. And obviously, they can also provide shading in the city by blocking out the sun and reducing the temperature at the surface. So let's talk a little bit more about this cooling process, again through the evapotranspiration. So when plants produce organic matter through photosynthesis, they basically are using sunlight and carbon dioxide from the atmosphere, and they're converting this to the organic matter, and at the same time they release water vapor into the atmosphere. We need water from the roots also for this process, and we release oxygen into the atmosphere. This is the photosynthesis and eventually the respiration of the plants. And again, if we would remove the vegetation from any location, then the energy from the sun doesn't go to produce photosynthesis and doesn't result in the evapotranspiration, and that sunlight will result in the heating. So when we remove trees and we put pavements over the parks, over green areas in the city, indirectly we're causing an additional warming in the cities. And here's a nice example of what we call a green roof, where we put vegetation on the top of a building, and you can see there's some lady here sunbathing on the roof as well. And basically, we can compare the temperatures on this roof over day and night and over the period of a month from July 2003. And we can measure the temperature on an adjacent building next door, which has no vegetation and doesn't have a green roof. And what we see here in the roof with no vegetation, we can see the gray or black line on this plot. And the green line is for this roof, the green roof. And what we see is, first of all, at the peak temperatures in the middle of the day, the temperatures are always lower on the green roof. And again, this is because the solar energy on the black roof or the black curve, all that solar energy is going to heating the roof. Whereas when we have vegetation on the roof, a lot of that energy is going to evaporate water and photosynthesis, and therefore less to heat. And so the maximum temperature on the green curve every day is a lot lower than the temperature on the non-vegetated roof. But if you look carefully, you'll also see that nighttime temperatures on the green roof are actually higher than the nighttime temperatures on the roof with no vegetation. And this is because also the vegetation, which has got water in its leaves, actually absorbs some of that heat being emitted from the roof at night, trapping in that heat. And so we have actually a slightly warmer temperatures at night on the green roofs, compared with the roof with no vegetation, where all of this radiation is emitted out to space, and we have cooler temperatures on the roof with no vegetation. So putting vegetation on the roof reduces the maximum temperature and increases the minimum temperature. We have less of a range of temperatures between day and night. If we look at the satellite image of Atlanta, Georgia in the United States, on the top is a visible image, and we can see where we have the built-up regions, the gray areas are where we have all the buildings and the roads and the infrastructure. The green areas are where we have more vegetation and the parks. And the bottom one is a thermal map showing the temperature of the different regions, and this ranges from about 18 degrees in the yellow up to about 30 degrees centigrade in the red. And you can see that the hottest regions are where we have the most built-up regions, or where we have the least vegetation in the city. Where we have the vegetation, we have the coolest temperatures. When we get rid of that vegetation, we don't have, again, that evaporation and the photosynthesis to use that energy in a different way, and that energy goes to heating up the surface. And the hottest temperatures in the cities are normally the regions with no vegetation. So there are many benefits for putting vegetation into our cities, on the roofs of our buildings, even around the building. What some people are talking about, urban agriculture, growing the food, even inside the cities. And this is part of what we call nature-based solutions to climate change, that we can use nature to help us solve some of the problems of the warm temperatures, the climate change, and give us also better life in our cities. So we can see some points here. Better water management, that basically green structures can also absorb the rainfall which is falling onto these buildings. Instead of running it off into the gutters and into the sewers, we can actually restore and keep that water where it's falling and use it for irrigation, for the vegetation on the building. As I mentioned, we have a reduced temperatures, reduced heat island effect. The more vegetation we have in our cities, the more green roofs we have. It provides better insulation for our buildings. Again, reduced temperatures on our rooftops, less air conditioners we'll need because we have less warm temperatures inside the buildings. We can also have, this improves the cooling systems, the energy efficiency of our buildings. It turns out that if we have really hot roofs or hot buildings, our air conditioning systems actually are less efficient. So if we decrease just by 1 degree the temperature of the building, we can actually increase the efficiency of the air conditioning by about 2%. And even the same is with the photovoltaics. If we want to put solar panels on our roofs, solar panels, the efficiency of them depends on the actual temperature of that roof. So if we put vegetation with the photovoltaic cells and cool down the roof, we can actually increase by 16% the efficiency of producing energy when we have a change in temperature. Storms, when we have rain, heavy rainfall, there's normally, again, what gets washed off the buildings through the gutters into the sewerage, but we can actually reduce the impact of severe storms. And even things like hail, which will hit buildings and hit the roof. If we have a cooler roof, we'll have less damage. It's less brittle, the materials on roofs of buildings, of houses. And obviously, if we have vegetation there, we bring birds, we bring insects, we have more biodiversity in the city for pollination of flowers, of plants, of vegetation. And so it's basically a win-win situation. By putting more vegetation in our cities, we both cool down the cities, we can work to solve some of the problems of climate change, and we can also help with biodiversity and increase nature in the city.